All right, we are talking now wireless Ethernet. All right, the cool thing about wireless Ethernet is it works a lot the same. There are some key differences, but it's a lot the same. So the frames are more or less the same, which means it's easy to do this sort of setup where we have, for example, here if I have a switch and I have, my server and I have another switch with my work group people connected to it. I'm not going to draw all these in. And I can just connect a wireless access point. I'm usually going to put AP for an access point. So I can connect a wireless access point to my switch that can either broadcast or receive from our mobile stations. Normally I'll draw a laptop for these. So we can send and receive from the mobile stations, and basically all that happens here, out here there's wireless frames. They are slightly different. We're not going to get into the frame structure though. And this just converts to a wired frame. Okay? So the access point can act basically as a bridge. As a bridge between the wired and the wireless network. That's the most simple operation. And that's what we're going to get into right now. Okay? A lot of times an access point will be used as a router, and that's what your home one is probably being used as. And anyway, it's more complicated. That's the bottom line. But we're going to be mostly talking in bridge mode. As we go to the next unit, when we talk about IP networking, and that'll be after spring break that we talk about that, then we'll get into what it means to be a router and what it does. Okay? The main differences right now is in media access control. And we'll talk about these in a minute. That's basically who can transmit. You guys remember when we talked about Ethernet, we said basically people just start transmitting and then they worry about the collision. You guys remember that? You just start sending something out and listen to see if there's a collision. In a wireless world, we don't want to have that. And then the other thing we worry about is, what's the other difference? Oh. It's also, we'll just generally say wireless sucks, so we have to deal with it. And we'll talk about how we deal with wireless transmission sucking in wireless Ethernet. So that's the basic idea. Who can yeah, I guess that should go over here. That's all right. All right, so let's talk about media access control. So if we draw our little access point here, I got my access point, and I have some stations on my wireless network. Okay, so these are people sitting around in a conference room, let's say, or in a classroom, and they have things they want to say. We understand, hopefully, I might as well draw this a different color. Let's draw it a nice blue. That if one station broadcasts, this is an omnidirectional antenna, right? And this means everybody else has to wait until the first one is done. And the waiting also includes the access point, all right? Remember that. What was the topology here? What's our topology? This is a bus topology. So the first thing we need to worry about is we need to make sure that people don't interfere with each other. We want to avoid interference, okay? And I guess we'll just move on over here. All right, so here's our technique. I'll draw a diagram over here again. So I got my access point. I'll draw my one person over here. And I'll draw my other person over here. Okay. So what do I want to do? What I'm using is what's called CSMA/CD. This is a lot like Ethernet. The CSMA is actually what the wired Ethernet uses. Oops, that's not CSMA/CD, sorry. CSMA/CD is the Ethernet on the wired. We transmit, it's like in the old technique, we transmit first and we ask questions later. We'll call it ask about collision later. So in the Ethernet world, when we're on that wire, everyone goes ahead and just transmits, and then we worry about a collision in a minute, okay? The thing about a wired situation is we can detect a collision immediately. I need to write these bigger, sorry. I'm going to write this bigger. So again, when we're in a wired situation, the collision can be detected as we're transmitting. As soon as the collision happens, I will, if I'm on my cable, get the message that there was a collision and I'll stop transmitting. In a wireless world, there's lots of times when I will not detect a collision. And I'll just show you one point here. Imagine, if you will, these two workstations are really, really far apart. I don't know. So there's 100 meters between the access point and this one, and 100 meters in the access point in this one. That means that when this one transmits, the access point can hear this one's transmission, but this station can't hear my transmission. Okay? The same thing goes over here. If this one transmits, the access point can hear it, but I can't hear this collision. That means if we both transmit at the same time, the access point will see that there is a collision, but neither one of us will know to stop transmitting. Y'all seeing that? So in wireless, we aren't all really connected to the same medium. There's those shadow zones. You guys remember that too? So if there was a wall somewhere in here, I might not be able to detect that I was getting interfered with. So again, in wireless, I might not detect the collision at all. And so I would just keep transmitting. And so I want to try to avoid that. Wireless uses CSMA and they use CA. And we'll talk about the ACK in a minute. So this is collision avoidance is what the CA stands for. So in wireless, I want to avoid a collision, and that's the important thing here, all right? So the process here is, in step one of this process, so let's say I want to transmit. I am going to be, let's see. So if I want to transmit, and if there has been traffic, well, we'll say if there's been no traffic, I will just go ahead. Okay? So again, let's put our stations back a little closer together. So I've been sitting here as a workstation, and let's say for the last 5 seconds, I haven't heard any wireless transmissions happening. If there haven't been any wireless transmissions happening, I'm going to assume that I'm pretty much alone. And since I'm alone, there is a low probability of a collision. So again, I haven't heard a lot of traffic, or haven't heard any traffic for a while, and therefore I'm going to assume I'm alone and it's okay to go ahead and transmit. So we'll put here little risk of collision, and then we will just transmit. All right? So that's if there's been no traffic at all. I'm just going to go ahead. And the second condition, if there is current traffic or, we'll just say recent traffic, that means there is a high risk of a collision. So here we're going to imagine, let's say I'm here again and I want to transmit. Shall I draw myself on here? So here I am and I want to transmit. Now in this situation I'm hearing, let's say this machine is transmitting right now. Okay? So I'm hearing them transmitting, and if I was just wanting to take turns, as soon as they're done, it would make sense that now it's my turn, right? But there's the risk. The problem is, if this station is transmitting right now, normally there's a receiver on the other end of it, and they are going to send a reply. Does that make sense? That's where the risk of a collision becomes high. If I'm hearing traffic, there's more likely to be more traffic, even if there's a momentary pause. So if this one stops transmitting, I can expect someone else to start also. And it's even worse if there's other stations around, right? And you remember here, in the old way, when we were on the wire, they can detect a collision immediately and everyone will stop transmitting. Over here, though, I can't be sure anyone will hear that I've collided with them anyway. So I want to avoid the collision. And so what I'm going to do is I'm going to wait. And this is kind of funny. I will pick a random number. And it's just a few milliseconds. So I'm going to wait a random amount of time, and then I'm going to listen again. And that's funny. So again, I've been hearing this one transmit, and then there's a pause. I'm going to wait a random amount of time. So I'm going to wait just a little bit longer, and then I'm going to listen again. During that time I'm waiting, the person they were talking to should reply back. If there's no reply, or if there's still a gap, if no one's still transmitting, then it's going to be okay for me to transmit. So this is continuing number 2. So we're going to be down here. If there is still no traffic, then I can send. If there is traffic, I need to wait again. That is, I set my random timer. That's kind of fun. So why do I set a random timer? The point here is 2 stations should wait a different amount of time. What I want to do is make sure that, for example, if I've been hearing, where was this one? If I've been hearing this one transmit and then this one goes dark, remember, I'm worried about me colliding with, for example, this person who wants to send at the same time. And what I need to do is make sure my timer is set to a different number than this one's timer. And I just pick it randomly, and then whoever's timer runs out first, they sort of win. So if, I pick 10 and they pick 3, then they go 3, 2, 1, boom, and they're done. And here I'm still on 7. And then when I get through my 6, 5, 4, 3, 2, 1, I'll hear them talking, and then I'll have to wait again. Okay, so there's like it's like a little contest. So again, if there's current traffic, there is a high risk of collision. That's either from, the reply coming back or another station that's waiting for this person to stop. Whew, that's fun. So again, it needs to be random because the 2 stations need to wait a different amount of time. Now the ACK. Oops. Mark. Pause for a moment for some grooming. See, now I'm glad he doesn't have me on the camera, right? All right, so what is the ACK? So remember we did, this is the same carrier sense multiple access, collision avoidance plus an ACK. So why do we have this ACK? Remember, wireless sucks, right? We'll put very vulnerable to propagation problems. We remember that, right? Wireless sucks. So point number one here is we need an ACK, number one, because wireless is very vulnerable to the propagation problems. And so what we need to do is we are going to acknowledge every frame. ACK. Every frame is acknowledged. If there is no ACK, the frame will be resent. What kind of protocol is this? This is now a, there you go, you guys are remembering this. This is a reliable protocol. Seems like that's going to be on the exam, doesn't it? Something about wireless needing to be reliable. So again, we need an ACK because wireless is super vulnerable to propagation problems. You know, we can't even be sure that we're going to get all our bits where they need to go. And for that reason, we acknowledge every frame. If it's not acknowledged, the frame is resent, and that makes us reliable. Now, the ACK is sent immediately. So if I go back to here, if my friend here, this is the other person on the network, if they were sending, remember I told you I was worried about a reply, because immediately the access point will send the acknowledgement. Okay? Because every frame is going to be acknowledged. And this is an important frame. So the ACK is sent immediately. This will happen while the other stations what are we going to call that? They count down their timers? Wait. So again, this station was sending. As soon as this station finished, these two set timers, remember? Meanwhile, the access point immediately sends the ACK. While the access point is sending the ACK, these two stations, you know, one of them the timer might have run out, and then they're like, whoa, the network's in use, and they have to wait. But the ACK goes in immediately. That's an important thing, because what happens if it doesn't come in? Then we're going to resend the frame, right? So if we don't get the ACK, the frame is going to be resent. And we don't want them to resend the frame because that sucks. It's going to tie up the network.
Also, can the ACKs create collisions?
Yes, it's possible to collide with an ACK too, but they are sent immediately. So the idea here is, remember, everyone is waiting. Everyone should be waiting when this person finished, so the ACK should be able to make it through. So it's like the ACKs are the most high priority thing in a wireless network.
Collided, then it would have to be resent the first frame and also collide with another frame.
Yeah. So there's a lot of potential problems here. So we'll just note this here. Wireless is a bit scary. There's lots of potential problems that can happen with wireless. Okay? This is not easy stuff, or to get it really working.